Hello, and thank you everyone for joining us today. My name is Sean Severson, co-founder and president of Water Tower Research and head of WTR Sustainable Investing and Climate Tech Research here at WTR. Glad to have everybody back again as part of our Sustainable Investing Fireside Chat Series. And as a reminder, this event will be archived and available on demand. You can ask questions in the bottom left-hand corner. There's a box called the chat box, which is easy to find, and you can ask questions there, and we'll get to hopefully a few of those. The format will be I'll run through a number of questions that we have, and then hopefully, like I said, leave some time for a couple questions from the participants as well. And today, we're glad to have Next Hydrogen Solutions, and I think in Reveal, I think we'll get a little bit about your background here as well. But the ticker, by the way, is NXT.V in Canada and NXHSF. And with that, I'll turn it over to you, Reveal. Tell us a little bit more about yourself, and from there, we'll get into questions.
Awesome. Thank you, Sean. Thank you for having us in your forum. My background, academic background, bachelor's in mathematics, bachelor's in economics, both from University of Waterloo, also a CFA charter holder. For the past decade, I've been focused in the sustainability space, consulting, venture capital, and equity research. Focus on sustainability space. Most recently, I was the lead equity research analyst for sustainability and special situations at Canaccord Genuity. I used to cover the hydrogen space, and that's where I met Next Hydrogen.
So let's talk about the basic investment thesis and how you see it from the inside. And kind of talk about the direction and the drivers that are making this an interesting space, and for Next Hydrogen's ability to execute on that.
Yes. So, I mean, the first thing is the market opportunity. Based on industry reports and industry experts, it's estimated that water electrolysis equipment alone is going to represent about 100 gigawatts of installation by 2030, which roughly equates to a US $80 billion market by 2030. And that is just the tip of the iceberg if you look at the projections coming out. So this market opportunity is humongous. And when we think about electrolysis, that's only 15%. So what I'm talking about is only 15% of the market opportunity. So a lot of ancillary revenue stream potential as well. Number two is we have an excellent team that is well positioned to capitalize on this large market opportunity. If you look at our product delivery team, starting with Matt Fairley, he was the Chief Technology Officer of Stewart Energy, Chair of U.S. Hydrogen Business Council, Vice Chair of U.S. Hydrogen Business Council, Chair of Canadian Hydrogen Business Council in the past, also Chair of California, also on the board of California's Hydrogen Business Council. Jim Hinatsu, Mike Stemp, our two co-founders, they, along with Matt Fairley, have been building electrolyzers since 1990s. First at Stewart Energy and then at Hydrogenics until 2007, and then they decided to co-found Next Hydrogen. And the team that comes with them from Doosan, from Tesla, from GE, all these other team members that we have, it's an excellent, excellent team. So the market opportunity is significant. The team is exceptionally good at capitalizing on this opportunity. And the third thing is, since 2008, we have been focused on bringing a very differentiated electrolyzer to the marketplace, which meets a well-defined market need. So what we are trying to do is take conventional old alkaline electrolyzers and bring in the flexibility that you expect using much more expensive PEM cells so that it better integrates with renewable energy resources and reduces the levelized cost of hydrogen. I'll expand more on that going forward. Moving on, we are very IP rich. So right now we are commercializing our 1 to 3 megawatt product line, but following that, you will see us not just bring the highest current density electrolyzers, but some of the largest alkaline electrolyzers in the marketplace as well. And then we have another PEM phase 0 study on the PEM electrolyzer program. So we are very well funded to achieve these opportunities. And the final thing is scarcity premium. This is a very large market opportunity. There's less than 10 notable players in the marketplace. We are the only notable player in Canada at this time, the most advanced player in Canada at this time. And when you think about pure plays, we understand we are the only publicly listed pure play in the electrolysis space. So just to summarize, very large market opportunity, the team, differentiated product offering, a very IP-rich company, and then the scarcity premium.
I mean, is there any part of that that's come, in recent times, to sort of an inflection point, I guess, if we were to look at it that way? Obviously, we look at the broader hydrogen market and fuel cells booming, right? And the very early stages of growth. But from the company and inside the company, are the things that have kind of differentiated over the last, 6 months, 12 months, whatever, that would, kind of give a new look for things as far as next hydrogen?
I think the biggest thing is we were severely undercapitalized for a long period of time. And over the last 12 months, we have raised about $64 million. We have grown our team from about 6 people in 2020 to about 40 people now, with an engineering team, with a manufacturing team, aftermarket service team, which we didn't have in the past. We implemented our ERP system. We moved into our new facility, which is a 20 megawatt facility on one shift, can do up to 3 shifts over there. So it's been quite a lot of progress at Next Hydrogen in the last 12 months.
Yeah, so then some money in the bank enables the growth, right? and to get things in position, for sure. So next question is a bigger picture question. Let's talk about hydrogen in general, and in particular green hydrogen. I think a lot of investors are familiar with the backdrop, but I think it's worth talking through it again and looking at what's driving it, regulatory, company, corporate responsibility, what you're seeing, and how the production of hydrogen fits into this and is critical for this.
Yes, so hydrogen, as you know, has had many cycles in the past, and it's struggled to take off. Why is that? Because for green hydrogen, 80% of the cost is renewable electricity, and 80% of the cost is renewable electricity. And that used to be 14 cents, 15 cents, then came down to 8 cents. And now in some jurisdictions, you're seeing it at 4 cents. And in some cases, curtailed electricity because of the supply-demand mismatch, allowing you to get renewable electricity for even cheaper. So that was a key prerequisite that we needed for green hydrogen to take off. And now we're seeing renewable electricity pricing come down to a place where we can see green hydrogen adoption rate and the cost of green hydrogen coming down substantially. Number 2 is, in some processes, it's very difficult to electrify them in order to decarbonize them. So think ammonia, cement, steel. These types of industries, they need a gas. You cannot electrify these industries economically. So how do you deal with the carbon emissions of these industries? That's where hydrogen can play a role. Same thing in heavy mobility. I think it's a misnomer to think that we somehow are not complementary to lithium-ion batteries. We are not competing with them. Think of us as battery extenders. What we are trying to do is have the trucks in the future that you'll see will have hydrogen cylinders up top. That'll feed into a fuel cell. The fuel cell will convert that hydrogen into electricity. That will keep charging us much smaller lithium-ion battery in real time. Why is that important? Because when you think about lithium-ion batteries, the way to think about that is in terms of megajoules per kilogram. For the amount of weight that they have, they can carry a relatively low amount of energy in them. So if you want to go long distances, the lithium-ion battery must, by physics, must get bigger and heavier and heavier. And that's a problem in heavy mobility because you need to carry the load on the trucks. You need that flexibility. And the second thing is, for 24/7 type of operations, you need faster fueling. And that's why in heavy mobility market, you're seeing some of the largest OEMs announcing program to launch hydrogen fuel cell powered trucks. And then it's the materials handling market. So forklifts, think about that. That market has already come alive. You brought up Plug Power, and Plug Power is doing an excellent job in that marketplace. So I think those are the types of factors that I would probably bring together.
So just going back to a little bit of a technical issue, let's talk about how electrolysis produces green hydrogen. And you touched on it some. Obviously, the power consumption is significant, right? So maybe just give a quick tutorial, if you can, on what electrolyzer does, and you touched on some of the renewable energy uses, but clarify what makes it green versus how it's being produced in other areas. But then also let's talk about the technology of the electrolysis.
Yes, so hydrogen already is about a $130 billion market in terms of sales. About 99% of that is gray hydrogen. Gray hydrogen is essentially produced using steam methane reformation, where you take steam and natural gas, you produce hydrogen, and about 12 kilograms of carbon emissions per kilogram of hydrogen that you produce. That's called gray hydrogen. Then you have blue hydrogen, which is exactly the same process, but you have carbon capture on the back end. Roughly, right now, you get about 6 kilograms of carbon emissions left behind for every kilogram of hydrogen that you produce. And then you have water electrolysis. What we do is the only way to produce green hydrogen. And the process here is simply electricity and water. You take electricity to break the water molecule into hydrogen and oxygen. And if you use renewable electricity, the hydrogen that's produced is called green hydrogen with no carbon emissions.
And maybe a little bit about the market for green hydrogen, the size of it. Obviously, like you said, if you really want to, you have a carbon reduction program and whether you're a fleet user of it or industrial production, the green hydrogen is becoming a very specific market, right, and of interest. Maybe talk a little bit about the drivers of why somebody chooses green versus others, and then maybe how you see the size of the market as well in terms of a total available market. I assume it's not all of the hydrogen market, but there's any place you're using gray or blue, you could use green and just get the carbon reduction that you need.
That's exactly right. I mean, that's why when people say, hey, what do you think about the blue hydrogen market? It's good for green hydrogen companies because they can open up the market opportunity and new applications for us, which we can eventually win, because there's good line of sight of green hydrogen being at parity, if not cheaper than blue hydrogen going into 2030. So all the markets that would be applicable to them will be applicable to us. And more so because of what we talked about with renewable electricity pricing, where that's going. Number two, 70% of the world GDP now has policies in place to grow the hydrogen economy. Look at even the US infrastructure plan that President Biden is proposing. I mean, and in Germany and in China and all these other countries, when you start adding all of this up, it's about 100 gigawatts just going into 2030. So what are the market applications? Starts off in materials handling. You have distribution centers. You want these forklifts to run 24/7. You don't want to use lead acid batteries. You want a new solution. That's where fuel cells are really taking off right now. Why? Because they can better withstand harsh environments. Asset utilization goes up substantially. Whereas with lead acid batteries, you need to have one lead acid battery in the forklift, one in spare, one being charged. So it really starts eating up time. So that's the first market that's already started moving. The second market is heavy mobility. Same reasons. You want a light truck. You want the truck to go a long distance and faster fueling because nothing kills margins the way low asset utilization can kill margins. Next up is industrial use. So think ammonia, cement, steel, those types of industries that already in many cases use hydrogen and are looking for a decarbonized source. So moving from gray hydrogen over to green hydrogen, and refining industry will be part of that as well. And then finally, where this goes is, I think, in the pipelines, so natural gas pipelines. If you think about electricity grid, I mean, they have renewable content, like 5%, in some cases 20% renewable content in them. But when you look at the natural gas pipelines, there's hardly any renewable content in those pipelines right now. So there's a big push right now. Is the electrification team going to continue eating the market share of the natural gas market? And in order to ensure that natural gas assets don't become stranded over time, it's an imperative for them to get more renewable content in there. And I think eventually what you'll start seeing is green hydrogen being blended into these natural gas pipelines, think 5%, 10% over time, to help ensure that natural gas pipeline companies can maintain their market share.
So I think it's pretty clear we've established, obviously, the market opportunity, significant growth. You're in a great industry. But let's talk about what's differentiated about Next Hydrogen and the competitive landscape. And obviously, you have a little better mousetrap, but maybe talk about how and why that is, and compare and contrast to your competitors, maybe who you view your primary competitors as well.
Yes. So, electrolysis is not something new. It's been around since 1930s, 1950s. Historically, what we used to have were alkaline electrolyzers. So it's just the cells I'm talking about, alkaline electrolyzers. And they would take steady amount of electricity coming in, low operating points because of the way the cell design architecture is, producing a steady amount of hydrogen that is then used in a downstream process. Used to work great. But the issue with alkaline electrolyzers is that they don't like to ramp up, ramp down very quickly. They don't work well with intermittent energy source. So as a result, the bright minds and capital started focusing on the on new cell materials, and hence you started seeing PEM electrolyzers. PEM electrolyzers provide you with the flexibility, high current density, quick dynamic response that you don't get with alkaline systems. But the issue is that they last about 60,000 hours. Alkaline cells can last about 90,000 hours. And then they use platinum group metals, which makes them significantly more expensive than alkaline cells. So because we had been building electrolyzers since 1990s, we said, is there a way to use the same cheap, durable, commercially proven alkaline cell materials and try to bring you the type of advantages that PEM is bringing in terms of high current density, better dynamic response. And so that's been the focus for the company. So we are trying to occupy this rare white space of giving you the cost and durability of alkaline while bringing you close to some of the performance characteristics of PEM electrolyzers, meaning in terms of current density. So a typical alkaline electrolyzer, and I'll try to quantify it for you. A typical alkaline electrolyzer will be in the 0.5 milliamps per centimeter square. Current density, our design enables about 1 amp per centimeter square. Why is that important? Because the more amount of electricity you can pass through the same cell materials, the more amount of hydrogen you can produce using the same cell materials. So you have a cost advantage. You're using less materials to produce the hydrogen. So current density is very important in that regard. So what we are talking about is current density, which is 2 times greater than traditional alkaline electrolyzers. Number 2 is the dynamic response. Our design enables ramp up, ramp down at about 5% per second. A typical alkaline system can be up to 5% per minute. And best PEM is about 10% per second. So we're getting you close to that same dynamic response you expect using PEM, but using cheaper and more durable alkaline cells. And the final thing is inherent scalability. And how we do it is we have completely revolutionized the cell design architecture, how fluids and gases are moving through an electrolyzer. It's the first real design change that I know of since 1950s. And enabled by that design change, we can make these systems very, very large. And if you can make these systems very, very large, you benefit from economies of scale. So together, high current density, resulting in less material use, dynamic response, allowing you to better capture renewable energy resources, and inherent scalability, leading to economies of scale. That's a very powerful combination to reduce the cost of electrolysis equipment.
And I guess let's talk about some of your relationships and how that's played out as well. I mean, talking about to date with AECL, Canadian Tire, Hyundai, Kia. I guess what investors are always looking for is some proof, right? Some evidence that somebody that's a lot smarter than us is working with you and why they're working with you. Sort of validation here. So maybe you can walk us through those relationships, how they came to be, why the choice is there. I assume this turns into case studies as well and data. But let's go to the drivers of what brought them to you.
Yes. So the good thing about these demonstrations that we have done so far is that our customers have publicly spoken in our favor following those demonstrations, which is very exciting, and you don't see that very often. So our first demonstration was with Atomic Energy Canada Limited. And now they're called Canadian Nuclear Labs, a blue chip organization, of course, over here in Canada. They needed an electrolyzer for CANDU reactor application. The electrolyzer that they needed was a high current density electrolyzer, which is why they selected us. It was a very successful project with them. In their management discussion and analysis, they publicly spoke about how successful that demonstration was with them. Unfortunately, the CANDU reactor market itself is a very small market, but at least it allowed us to show our high current density functionality. Number 2 was Canadian Tire. They were switching their forklifts over from lead acid batteries to fuel cell forklifts, and they bought our system in 2014. It was a 0.4 megawatt system for test and evaluation of these forklifts. The system ran based on their requirements between 2014 and 2019. We had an independent third party come and validate the system in the middle as well. Canadian Tire publicly spoke about the success of this project, and the proof's in the pudding. We got orders for 2 systems, both about 1.8 megawatts on the back of this demonstration. And more recent, and that's what we are scaling up to now that we're well capitalized. That was the big issue for us. We were not well capitalized. Now we're well capitalized. So we are scaling our systems up to these 1.8 megawatt size. This is a pretty big system. Can produce about 650 kilograms of hydrogen per day, enough to power about 200 forklifts. So a very, very big system for the distribution on-site distribution market. and that's we are delivering that next year. And then the final thing with Hyundai and Kia, so they due diligence us for I think over a year, and on the back of that, they put out a very complimentary quote about our unique design in the press release that came out and called a state-of-the-art water electrolysis company. So it's a very unique design. These partnerships, the public comments that we have received, we are very grateful for. Plus, these new partnerships have gone a long way in validating how unique our value proposition is.
And I think that validation is critical to point out, right? Because there's when growth companies reach inflection points. It usually takes some partner like that or pilot programs to create the data and create the in-field operations, right? So, I guess as you look at where you sit today, you kind of have that portfolio of proof, let's call it, the data, to really extend this and really be able to grow sales without having to run through these trial processes again. Is that correct?
So we have good data on smaller systems. What I want next is data on multi-megawatt systems. So that's the focus for us going into 2022. And then our objective is to enter large volume commercial sales in 2023. So in order for me to enter large volume commercial sales in 2023, what do I need? I need people. So my team's almost fully built out now. As I mentioned, we are at 40 people and going to 60, but the key leaders and all the different product delivery team functions are all here. Number two is you need an assembly facility that's running on an ERP system, because otherwise it's difficult to scale. All established. Next up, for 2022, we are planning about 5 demonstrations, and we want to run them in very different applications to make sure that we get 5,000 hours or more runtime on multiple in various environments. And at the same time, we're working on a supply chain objectives. And so together with those, we think we are going to enter large volume commercial sales in 2023 based on some of these milestones. And of course, we are in discussions about potential other strategic partners as well. So we hope that we can achieve some of that next year too, because what we really want are not customers, we want partners. And the types of partners we are looking for are those who can either scale us up, bring a large end market to us, be our go-to market partners. So very exciting 2022 coming up for us.
Well, that's a great lead in my next question. Something very near and dear to my heart as an analyst is what are the catalysts? Sitting outside the company, we're looking for ways to track progress, right? That evidence that you continue to go in the direction you say you're going. And so as we look out over the next 18 months, maybe a little longer, you talk about different time frames, but what things would happen that show that you're executing to this plan towards 2023 commercialization? I know you mentioned some of them, but some of these things can be specifically mentioned and press released, or how will this work?
Yes, so I think demonstrations being press released is going to be big for us. Number two, strategic partnerships will be very important, but fundamentally speaking, this that's only the tip of the iceberg. What's happening behind the scenes is equally important, and which is difficult to see, which is making sure that our manufacturing operations, our assembly operations are very robust. And that's a key focus for us at this time. So I think demonstrations, strategic partnerships will be very big, but there's going to be a lot happening behind the scenes as well in order to deliver on our 2023 initiatives. The next thing after those two things will be the reduction in cost for our systems, some of the supply chain initiatives, low-cost country strategy that's underway right now.
So let's go back to, obviously, a big part of this and inflection point has been the financial condition of the company and having the capital. Can you just can you summarize that and talk about how you might use that money and where how you're going to spend it and what the future looks like in the current financial situation as well?
Yeah, so we have about $45 million of cash, no debt on the balance sheet. If we continue running as hard as we want to run, that lasts about 2 years without any government grants. Without any government grants is an important point to mention. And if we want to reduce the pace, which we don't anticipate, we can bring our cost down to about $8 million per year. So 2 to 4 years is the runway we have with this cash. The bulk of this cash right now is going towards product development. As I mentioned, we have a 1 to 3 megawatt product line, which we are on the cusp of bringing to the marketplace. And then you have much larger product lines. So that's about $20 million worth of R&D expense for us. That's where that is going. And the rest is about getting our assembly facility up and running. It's relatively low cost, if you can believe it, because it's not a manufacturing facility, it's an assembly facility. The cost on that is about $3 million, primarily for the cranes that we need. So for $3 million, we're getting a 20 megawatt facility on one shift. So shows how we can scale that up. And the final big expense for us is going to be on these demonstrations. We make sure we do it right. You only get one chance to build a strong brand, and this is our time to build a very strong brand with our partners.
Great. Well, thanks, Ravil. That finishes my questions, and I want to leave a little bit of time here to take some questions from the audience. The first one we have is you mentioned cost reduction. I got a couple questions on this of your product. What does that cost curve look like? And it's a great question because we all know that this is, as costs go down, price elasticity and demand and all the other things that go along with it. So maybe some specifics on that would be very helpful.
Yeah, so we have not disclosed publicly what our cost target is for 2023, but of course it's cost competitive with where the pricing is right now, which is about $1 million per megawatt for the systems. And of course, we want to make positive margins going into 2023 associated with the system. I can speak more about like how we are going to achieve that in terms of bringing our cost down. So number one is the BOP. The balance of plant is about 50% of the cost of a 1-2 megawatt system, and there's substantial opportunities based on commercially available materials to bring down the cost over there. Next up is scale up of the systems. Right now we have 3 modules in the system. Our objective is to bring it to 2 modules, and that's going to result in significant cost savings as well. And the third thing is, you are seeing such innovation in cell materials, cell components, that now we're well capitalized to drop into our electrolysis. It's not a big technical feat for us to get that thing done. And we are testing some of those new cell materials, cell components. So going into 2023, all of these 3 things, the BOP optimization initiative, balance of plant optimization initiative, and just for reference, that's the hydrogen skid, the oxygen skid, the water purification rectifier, those types of things in there. So there's a lot of opportunity, low-hanging fruit to optimize the balance of plant costs. Then we talked about reduction in the number of parts we have in our electrolyzer module, and the third thing is cell electrical efficiency. So that's our roadmap.
Thanks, Ravil. Next question is, who do you view as your main competitors?
I would say probably Nel. Nel is our biggest competitor right now. They are a very well-established player in the marketplace with good reference sites, especially on the alkaline side. I would say them. Other players in the space are McPhee Energy, ITM Power. Thesis Group is doing a good job in the space as well, and Siemens. We have another new company that recently got publicly listed. It's called Green Hydrogen Systems. So all in all, when you think about notable players, there's of course smaller players who are trying to get into this place, but notable players, there's less than 10, and a very large market opportunity.
That actually ties in well with another questions we're getting about your patent portfolio, and maybe I can ask it in a different way and say, where and how are you differentiated? Obviously, you have an IP portfolio that's pretty substantial, but how do you protect that? Are there any Leapfrog technologies that are out there, or real changes in the technology that you're aware of that we have to watch for?
So we have 38 patents on our core design. It's a very unique design. It's not in the marketplace right now. And even if someone wants to copy that and bring that into the marketplace, it'll take many years to perfect that. And there's a lot of stuff which is know-how, a lot of stuff in the models that we have that's not in the patent portfolio, of course. So it's difficult to replicate us. And of course, we have patents in all the key jurisdictions, and we understand how to support our IP portfolio and litigate if necessary. We have that expertise in-house. The second thing is, of course, there are new technologies coming in, a lot of exciting developments that are coming in. A lot of these companies are looking to partner with us, because the way to think about us is that we create the body of the car. Cell design architecture, how we're managing fluids and gases, think about that as the body of the car. What engine we put in there is is agnostic. I mean, the body of the car is agnostic to what engine you put in it, in simple terms. So if you start seeing some of the new cell materials, cell components come in, I mean, that'll be complementary to us. It'll actually be beneficial to us because we are making the body of the car. The engine can be improved on, and some companies are doing some really good jobs in that, and we are speaking with them. So we are very mindful of what's coming in the rearview mirror, and there's partnership opportunities to be had, especially given our flexible cell design architecture that can test out new engines. So we are making some progress on that.
Great, thank you, Ravel. We're at 30 minutes past, so I'm going to make this the last question we're taking, and it's a good one. It's on your technology roadmap, and we touched on it a little different, a couple different ways during today's fireside chat. But let's look at the bigger picture for the technology roadmap. What you see, where you're going to spend that money in R&D, for example, and what it means and timing of these of the spend.
The most amount of money that we are spending right now in terms of product development. And by the way, I mean, if you're an electrolysis company, by 2025, you should be targeting dollars per megawatt of 500 per kilowatt by 2025. If you're not in that ballpark, it's a problem. So we are well positioned to hit that, if not exceed that. How are we going to do it? So where our focus is right now in terms of that, number one is reducing the number of parts of our electrolyzer. We have a good plan around that, and also scale up of the electrolyzer. So those are two areas which will both help. Reducing parts is obvious. Scale up, why that's important is because that helps you rationalize the balance of plant too. So for example, when you think about a 6 megawatt solution versus a 2 megawatt solution, the balance of plant cost does not scale linearly as you go to 3 times the output. So so think about reducing parts, scale up of the system, then along with the rationalization of the balance of plant, you also have optimization of the balance of plant, so reducing the cost of balance of plant. And then the final thing is in improving the efficiency of our systems. There's a lot of good work that's being done on polarization curves that we think we're going to leverage, and the market will see that going into 2023.
Great, thanks. It's been very helpful, and I'll turn it over to you for any closing remarks that you have. But I think this is very informative, and what's a super unique market and growing market that investors are looking for, looking for new opportunities. So I'll turn it over to you for any closing remarks, and then I'll finish up.
Yeah, I'm very appreciative of this opportunity. We are chasing a goal which is bigger than ourselves. So if there's any strategics or any potential customers listening on to this call, I would say we are all about collaboration. Because the pie is too big for us to want to have it all to ourselves. We want to collaborate, and the objective has to be bigger than just what we are trying to do. It's a bigger objective, which is about decarbonizing our planet, and that's very important this decade, and we want to focus on that. We think the market opportunity is huge. We have the right people in place. We have a differentiated product offering. We are very IP rich, and now we're also cash rich. So we are well positioned to execute on this market opportunity. Thank you for listening, and thank you for the support.
Great. And thanks for everybody participating today. As a reminder, you can access all of our research, open access, non-permissioned research at www.watertowerresearch.com. And you can look at, you can access this event on there as well, of course. But I encourage you to take a look at some of the content research on that site. Again, thank you for everybody joining us today, and we look forward to having everybody back. Thanks, Ravel.
Thank you, Sean.